This lesson we're going to take a look at tests for parallelograms, which means we're going to look at a quadrilateral and figure out if it is a parallelogram or not. Now what I want us to think back to is what we learned the other day about parallelograms. So we had one statement that said if the quadrilateral is a parallelogram, then the opposite sides are congruent. We also had another one that said that the opposite angles are congruent. We know the consecutive angles are supplementary. We know the diagonals bisect each other, and we know if one of the diagonals, or if the diagonal will cut the parallelogram into two congruent triangles. We know all of these things. Remember, now this says if the quadrilateral is a parallelogram. So we first know it's a parallelogram, then we know all of these things. Now the other one, so what we're going to do today is we're going to look at the converse. So here's that original statement that we had from the other day. I'm going to take a look at the converse, which says if the opposite sides of a quadrilateral are congruent, then it is a parallelogram. I want to know, is this a true statement or a false statement? Hence is the converse true or not? So I look at this and, well, I got to go back to my definition of a parallelogram. It says a quadrilateral with two sets of parallel sides. So somehow if I could prove that the single ticked sides and the double ticked sides are parallel, then I'll know that it is a parallelogram. So what I'm going to do to start here is I'm going to take and I'm going to create a diagonal. Now what that does for me is that creates two triangles, and when I look at this, now I have single tick, double tick, triple tick on the bottom triangle, and I have single tick, double tick, triple tick on the top triangle. SSS tells me the triangles are congruent. And if the triangles are congruent, then I know all the corresponding parts. In this case, it's going to be the corresponding angles are going to be congruent. So I know that, well, actually I'm going to go like this. I'm going to go, this angle here is congruent to this angle here. And then I can use properties that says that if alternate interior angles are congruent, which these are, then lines are parallel. Well, that's going to be this one and this one. So right now I know that I have one set of parallel sides. Well, I can come back here and go back to my congruent triangles. Here's another pair of corresponding angles in the two triangles. Those are congruent. But I can also look at those as alternate interior angles. They're congruent, which means the lines are parallel. And that's this one and this one. Now I have a quadrilateral that has two sets of parallel sides, which means it is a parallelogram. So is this one true? Yes, it is. Which tells us if you ever have a four-sided figure quadrilateral where you know the opposite sides are congruent, this part right here, if you know that, then you know that it's a parallelogram. Now the next one that I had up there from the other day was the one that said, well, the opposite angles are congruent. I'm going to look at the converse of that one. So if the opposite angles of a quadrilateral are congruent, then it is a parallelogram. So what I've done here is I've marked up my quadrilateral, showing that the opposite angles are congruent. Now what I'm going to do on this one is I'm going to say, well, I don't know the measure of any of these angles, but I'm going to call that one x, which means this one has to be x. And I'm going to call this one y, which means this one has to be y. And I think back to what we did in the first section on this chapter where we said, well, in a quadrilateral, the four angles added together is 360 degrees. Well, then I'm going to take my four angles, I'm going to add them together, and it's going to equal 360 degrees. Now if I go through and I solve this, now I'm left with 2x plus 2y equal to 180 degrees. And continue on, getting this a little cleaner. And I can do that by dividing both sides by 2. And when I do that, I end up with x plus y equal to 180, and this would be degrees. Now, some of you look at that and go, well, you haven't solved the equation, Mr. No, but what I've done is I've just told myself that x and y added together equals 180 degrees. Now I look at this in terms of the top and the bottom of my quadrilateral as two lines. These are consecutive interior angles, and if the consecutive interior angles are supplementary, then the lines are parallel. And I can do the same thing, but now go this way. These are consecutive interior angles between the left and the right side. Consecutive interior angles are supplementary, which means the lines are parallel. And what do you know? I have a parallelogram again. So is this converse true? Yes, it is. So if the opposite angles of a quadrilateral are congruent, yes, then I have a parallelogram. Another one. This one said the consecutive interior angles are supplementary. Is it a parallelogram? Well, yeah, that's essentially what I just did in the last one. I figured out that this angle and this angle, if they add up to 180 degrees, well, they're consecutive interior angles for the top and the bottom. They have to be parallel. But then if I go like this, those are consecutive interior angles that are supplementary, which means that these two sides are parallel. And yes, my converse is true. So I have another test. If I know that the consecutive interior angles of a quadrilateral are supplementary, yes, I have a parallelogram. Next one, this one said that the diagonals bisect each other. I'm going to look at the converse, see if it's true. So I have my statement that says if the diagonals of a quadrilateral bisect each other, then it is a parallelogram. And I'm going to try to figure out, I'm going to prove to myself that it is true or it's not true. I have my quadrilateral. I've shown with the ticks that my diagonals are bisecting each other. And I want to somehow prove that it's a parallelogram. What I'm going to do is I'm going to look at this triangle here on the left and this triangle here on the right. I'm going to know that those two triangles are congruent because the vertical angles are congruent, and now I have side angle side in both of them. Therefore, the triangles are congruent, which is going to be helpful to me because that's going to prove that this angle and this angle are congruent. Now, if I look at those two, those are alternate interior angles for the left and the right side, and that's going to tell me that this side is parallel to this one. But then I can use those same two triangles, looking at them, and being that those two triangles are congruent, that's going to tell me that this angle and this angle are congruent. But that's going to do the same thing for me. I guess I don't really need that one because these are alternate interior angles again, but those are for the same two sides. I'm just showing that those are parallel again. What I need to do this time is I need to come back here and go, well, now let's look at this vertical angle and this vertical angle be congruent, because now I have the bottom triangle, and I know there's going to be a lot of stuff in this picture, and the top triangle being congruent. And if the top and the bottom triangles are congruent, corresponding angles are congruent, so now I'm going to need 4 arcs here with 4 arcs here. And these are alternate interior angles for the top and the bottom sides. And if the alternate interior angles are congruent, then the lines are parallel. So again, I have one set of parallel sides, 2 sets of parallel sides. I have a parallelogram. So when it's all said and done, if the diagonals of a quadrilateral bisect each other, then yes, it will be a parallelogram, and this converse is true. Well, now I come here. This was the last one from the other day that I'm going to look at today. It says if quadrilateral is a parallelogram, then each diagonal cuts the parallelogram into 2 congruent triangles. Well, the converse, as you see right here, right there. Now I'm just going to look at one of these. Now, this one tells me that the 2 triangles are congruent, top and the bottom. Well, this goes back to the very first one that I talked about. If I proved that these 2 triangles were congruent, it went on, I had alternate interior angles being congruent, and eventually I ended up with my 2 sides being parallel here, and then if I drew in the other diagonal and looked at it, it would prove that these 2 sides are parallel. So yes, I have a parallelogram. This converse is also true. So there you have 5 different tests to see if a quadrilateral is a parallelogram. And then I have one more that we're going to take a look at. That's this last one that I have hidden. guess I didn't really need to go back here, but I did. And here it is. So it says if I have a quadrilateral with one pair of sides that's both parallel and congruent, then it is a parallelogram. Well, based off what we had so far, we wouldn't be able to say it because we'd have to have two sets of sides being congruent or two sets of sides being parallel. But when I look at this one, I can come back here and I can put in this diagonal like I did in a couple of the other ones. And being the top and the bottom in this case are parallel, then the alternate interior angles are congruent. And I can also, so that's one. Then I'm going to continue on and look at that green the green diagonal I put in. That'd be congruent to itself. And now when I look at this, I have single tick, single arc, double tick on the top triangle, and single tick, single arc, double tick on the bottom triangle. The top and the bottom triangles are congruent. And now that the triangles are congruent, I can look at those corresponding angles. They have to be congruent as well. Here would be one of them. Here's the other corresponding angle to it. And then I look at those two and I say, well, these are alternate interior angles for the left and the right side, which tells me that the left and the right are also parallel. And now I have a quadrilateral with two sets of parallel sides. So is this statement true? Yes, it is true. So I have 6 tests now to see if quadrilaterals are actually parallelograms or not. So the first one, let me bring you all the way back, quick review, right here. So if you know the opposite sides are congruent, you know it's a parallelogram. If you know the opposite angles are congruent, then you're going to know it's a parallelogram. If you know the consecutive angles are supplementary, then it's a parallelogram. If you know the diagonals bisect each other, it will be a parallelogram. And if you know that the diagonals, or each diagonal cuts the quadrilateral into 2 congruent triangles, yes, in fact, it will be a parallelogram. And then the last one, if you have one set of parallel and congruent sides, it's going to be a parallelogram. So keep those 6 tests in your head as you move on, and you'll be able to figure out if quadrilaterals are parallelograms or not. And I'm going to conclude my video lesson right now.